types of transformations there are. And one thing about this stuff is towards the end of the semester, the second half of the semester, we do trigonometry and you redo graphing. So it's real helpful to understand how transformations work for any type of graph of a function that you have. So we're going to do some things that are actually pretty simple tonight in learning this. So the first thing that we're going to look at is we're going to just look at graphing y equals absolute value of x. Now, it depends on your background. Absolute value functions generally just kind of look like a V shape, kind of like that. So what we're going to do first of all, before we do anything with that negative, we're going to just fill out this table of values. That's what I'm going to do tonight, is just mostly tables of values and then show you how the different part of the problem transforms that graph. So what we're going to do here is when we fill this out, see, we're just doing absolute value of -2, so that's 2. And you just do this in your head. You don't have to put that absolute value. That's 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, like that. Okay, so we're just going to fill out a table of values. Ultimately, you want to get to where you know these basic functions real easily so you can create that graph real easily. So what you want to do now is you want to go ahead and graph that. I think my y-axis got a little bit messed up on this, so I need to be kind of careful about that then. Actually, let me do this real quick because I think this might mess something up here if I use that graph. So let me just do one thing here real quick. I do this all the time when I'm making up stuff. I just go look on the internet and I find a graph. I'm just going to take a snapshot of one, and then that axis won't be all screwed up. Because when it exported, I think it got kind of messed up there. Is it like that on your paper, or is it okay? Okay. Is it okay? Okay. All right. I just did something when I exported this, I think, to OneNote like I'm used to using. And then I can just paste that over this same thing over everything as I do this then. Okay, so what you want to go ahead and do is just go ahead and graph the points on your graph. Then we'll talk about how that negative affects everything then, and then I should be able to use that graph over and over again here. Okay, so if we go through and graph that, we just have the point -2, 2. We have the point -1, 1, 0, 0, 1, 1, and then 2, 2, like that. And then that will give you the graph of y equals absolute value of x, like that. And then what we call that is we call that an elementary function, or sometimes a parent function. And then this thing right here, what does that negative do? That negative just multiplies all those y values by a negative. Because this is saying take the absolute value, then multiply it by negative. So that's going to be -2, -1, and so forth like that. So what I want to do with that then is, I'll just do this in a different color. That's -2, -1. That's still 0, -1, -2, like that. Then you want to go ahead and plot those points. So you would have -2, -2. So you'd be going left 2, down 2. -1, -1 would be like this, and so forth. Okay, so just get all those points plotted out, and then connect the dots like that, and then let's label that as the graph of y equals negative absolute value of x, like that. Okay, so what we call that is we call that a reflection. We've already talked about symmetry and reflections. We call that a vertical reflection. Anytime that you have a negative in front of a basic function, it changes all the y values to negatives, and that's what causes that to flip over the x-axis. Does that make sense? Okay, yeah.
On our test, when we're making a graph, do you want us to write the equation for every graph that we do?
No, generally when I'm not knowing that, generally what I have you do is do the elementary. You don't necessarily have to label it. I'm going to know which is which. And sometimes I have to do a table of values, sometimes I don't. But generally, if you had that there without the label, I'm not going to count you wrong, because it's got to be right, okay? All right, so let's go and let's look at this next one here. And with this one's the same thing. We're going to go over all these transformations, and we're just going to generally do about 2 examples of each. Okay, from your background, you probably know x squared is the parabola. Okay, so I'm going to go ahead and we're going to put that together. We start by doing what we call the elementary function, or the parent function. And you guys can do this in your head. All you're doing is just squaring those numbers. So that's going to be positive 4, positive 1, 0, 1, and 4. Okay, you don't have to write down that you're squaring it. You can just square that out. So that's 4, 1, 0, 1, 4 like that. And then you want to go ahead and just plot those points. That will give you what we call the parabola. So I'm going to go left 2 up 4, left 1 up 1, 0, 0, and then 2, 4 like that. And then I am going to label that as y equals x squared, okay? So actually, what is that negative going to do? It's going to do the same thing, isn't it? That is just taking all of those numbers, all the y values, and multiplying by -1. You can do that in your head. You don't have to show that out. Just need to understand that that would become -4, -1. That's still 0, -1, and -4 like that. Then if you plot your points, you're going to have, let's see, you'll have over 2 to the left, down 4, left 1, down 1, 0, 0, and so forth like that. Okay? This is usually the easiest transformation for students to understand. It's just how that reflection works. Okay? Now, as we go through, I want to remember to put the domain and range on there. So is everybody with me what I'm doing with the basic graph? We kind of build up from simple to a little bit more complex as we go. So we're going to do just kind of one transformation at a time. Okay, so what I'm asking you to do on this is what's the domain and range of the final product. So the domain would be what can x be? Is there anything that you can't take an absolute value of? Now, you can take an absolute value of any number, right? 0, positives, negatives, and so forth. And look at my graph anyway. It's going to go on forever. Okay, so the domain is this way, so it's all real numbers. So what we're going to write if the domain's all real numbers, how do you write all real numbers in an interval notation? Negative infinity, infinity. Okay, good. When I'm asking for the range, what are you looking for? Y values. Okay, don't look at the blue graph, just the red one. So that's really ranging from forever down there until we get to 0. So how do you write forever down there to 0 in interval notation? Negative infinity, comma 0 with a bracket. And you have to have a bracket because that's an included point on there. Okay, so you got to write that, the range in interval notation like this. Okay, it gets forever negative, 0 in a bracket like that. Okay, look at the domain on the parabola. Is it any different? Same thing. You can take any number and square it. There's no number you can think of that you cannot square. So the domain is everything. The range is still the same thing. It's negative infinity until you get to that point right there, because that's the blue graph right there. So the answers to domain and range are exactly the same on both of these problems, okay? Like that. Everybody with me there and okay what I mean by that? Okay. Okay, so that's a transformation like that. So what your goal on this is no matter what your function is, I mean, you could have a function of all sorts. You could have like a square root. If you put a negative in it, it's just going to reflect that over the x-axis. That's the idea. And that's what you want to be able to quickly see, okay, and understand why that works out. Okay, let's go to the next one. And what we're going to do now, I'm going to do one more with the square root just because of there's something a little bit different about a square root that I want to talk about here. And what we're going to do is the first thing we're going to do is we're going to do the square root of x, okay? Now notice on this problem, I didn't use the same numbers I did on the other one. Why do you think I started at 0 and went that way? Because on a square root, you can only do a square root of positive numbers and 0, right? Okay, so if you plugged in -1 there, the square root of -1 is an imaginary number, so you can't do that. So that's the reason I plugged those numbers in the way I did. So if you just did this in your head, that's square root of 0, so that's 0. This is square root of 1, so that's 1. And then what you'd have here, square root of 2, that's really 1.4 if you did that on the calculator. And then if you did square root of 3, that's not a whole number. If you did it on a calculator, you'd have 1.7. And then finally, square root of 4 would give 2 like that. Okay? So if you go through and plot those points, the elementary function is going to kind of look like this. We have 0, 0. We have 1, 1. Then I'm just going to go to 4, 2, and then forget about those decimals. And then I'm going to go ahead this time just use a dashed line. and then label that as that's the function y equals square root of x, okay? What's the domain of that function? 0 to infinity. Does the 0 include?
Yes.
Yeah, because you can do square root of 0. Okay, what's the range of that function we drew? 0 to infinity. So the lowest y is 0, but then it gets higher forever like that. Okay, same thing. All you're going to do on this is the final product. You're just taking all those things and multiplying by -1, so you get 0, -1, -1.4, -1.7, -2 like that. You graph them, and what's that going to do? It's going to reflect everything over the x-axis. Okay, so if you put those things in, then you'll end up with your final graph looking like that. So that's what we call a vertical reflection. Okay, all right. What is the domain of this one I drew in blue? That's 0 to infinity. What's the range now? It's different. Okay, it's negative infinity all the way to 0. It doesn't go beyond that. Okay, everybody okay with that? Okay. All right, so we would write that domain as bracket 0 to infinity. You can do a square root of 0, that's why you include it, and then negative infinity to 0 with a bracket there. Okay, any question about that? Okay, so when you learn graphing, what it really boils down to is arithmetic and plotting points when you're just beginning to learn the basic functions, because you got to be able to do those two things well. Okay, that'll take care of a reflection. Now what we're going to do now is a vertical translation. And I'll show you kind of how this one works as well. This is another one I think students usually right on top of this one. It's not real hard to understand. So we're going to go ahead and do this graph. And what I'm doing now is I'm taking what I call an elementary function. X squared, you want to know immediately that, okay, that's the parabola. Okay, and then we're going to kind of look at what happens if you put another number in it like you add or subtract. That's the idea. So what we're going to do is just kind of quickly plug this in. Okay, now you can do this in your head. When you're doing y equals x squared, you just square all of these x numbers in your head. So that would be 4, 1, 0, 1, and 4. So I do that. Then you want to plot those points, and I'm just going to again use like a dashed line on that. So I'm going left 2, up 4, and then left 1, up 1, 0, 0, and so forth. Okay. Let me ask you a question on this. Okay, is that an even or an odd function that I just graphed? It's even. Okay, it's why? How's it symmetrical? Not the y-axis. There you go. Okay, just to see if you remember what I taught you maybe a few classes ago. Okay, right? It's an even function. That's what even functions look like, because they're symmetrical about the y-axis. Okay, now here's what happens when you do that -4. All you're doing is you're taking that thing minus 4. You do this in your head. 4 minus 4 is 0. 1 minus 4 is -3, and so forth. So you want to understand clearly how the arithmetic goes. And you can do that in your head. You don't have to write out what I'm doing here. So I'm just going like 1 minus 4, 0 minus 4, and so forth. So what you would end up basically having on that is you would have that then. Now, if you go through and plot this set of points, you're going to see how the transformation goes. So we would just now have -2, let's see, -2, 0 would be a point. -1, -3 would be a point. 0, -4 would be a point, and so forth. So if you get those points plotted, then your graph is going to look like that then. Okay, so what happened? Shifted down 4. So we call that a vertical translation. Just means that -4 caused everything in that elementary function to go down 4. Does that make sense? Okay. You're just making the y values get smaller by 4. Therefore, that's what's going to happen.
Could we just consider that as like the y-intercept because it's essentially b because y?
No, not. Yeah, well, you're thinking of y equals mx plus b. That's a line. You are correct on this problem. That is a y-intercept, but not because of the form that we have for a line. It's more like, if x is 0, you get y equals -4. The way you find a y-intercept is you just look what happens when x is 0. I think you're thinking of y equals mx plus b. You're thinking of that minus 4 as b. Technically, that's not really what it is. Okay, but it is a y-intercept on that. Okay, what would be the domain of the green graph up here? It's everything, all real numbers. You can square any number. What would be the range this time? The lowest is -4, right? The lowest y is -4, and then they get bigger. So how are you going to write that?
-4 bracket.
Yeah, you got to have -4 bracket and then infinity like that. That's how that goes, okay? All right, everybody with me there? Okay, so that's what happens. Now this next one, if you caught on to that, you can tell me what happens. How did the absolute value look? We graphed that a few minutes ago. What was that? That was the v, right? So what's that 3 going to do to it? It's going to shift it up. When you're adding, you're making the y values get bigger by 3. So that's what's happening. Right, so what we'll do with that, I want to do one more of those. And again, we're going to kind of look at all the basic transformations, and we're going to kind of begin to put them all together. Okay, so this first one, just do the absolute value. That's going to be 2, 1, 0, 1, 2, and then you go ahead and graph what you call your elementary function. So we'll have -2, 2, -1, 1, 0, 0, and so forth like that. Okay, so that's my elementary function like that. Now again, all you're doing is you're just adding 3. Those numbers get bigger by 3. That's what makes it all go up by 3. So you can do that in your head if you want to. So 2 plus 3 is 5, 1 plus 3 is 4, 0 plus 3 is 3, and so forth like that. So if you plot those points, then all these points go up 3. So you'd have -2, 5. You would have -1, 4, 0, 3, and so forth like that. Okay, so that's what your final graph looks like. That's y equals 3 plus absolute value of x. Okay? All right, what's the domain of the final product, the one in blue? Everything, all real numbers. How about the range? Where to where? 3 to infinity. Okay, range is y. That's your lowest y. 3 to infinity like that. Okay, so we just say -infinity to infinity for the domain. Then we say bracket 3 to infinity for the range like that. Okay, so it's real simple. If you take this problem I have on the board, the square root's the one that went like that. That would reflect it. So if I did like a +8, what would that do? Just takes the whole thing up 8. What if I do a -8? What does that do? That takes it down 8. Now once you start learning all these transformations, you got to be able to spot why that happens. This is outside of that function. Since it's outside of it, that's what causes it to move up or down, like that, okay? Okay, next one is what we call a horizontal translation. This one's the one that's a little bit harder for students to understand. The calculations are pretty straightforward on this. So I haven't done a cubic function yet, so we're going to go ahead and do the graph of y equals x to the third to start with. And again, all you're doing on this is you're just cubing this. I don't care if you do this in your head. So if you do -2 to the third, that's -8. You're multiplying a negative out 3 times. That's why you get a negative. If you do -1 to the third, that gives -1. 0 to the third is going to give 0. 1 to the third is going to give 1. And then 2 to the third is going to give 8 like that. Okay? So let's go ahead and let's plot that. That's what you call your elementary function. So you want to get that kind of put together. And just kind of connect the dots into that curve like that. So that will be what we call our elementary function, y equals x to the third. Okay, just a minute before I finish this problem, what kind of function is that? Is it odd or even? How's it symmetrical? Let me ask you that. It's symmetrical about the origin, right? And remember what we learned about symmetry is origin symmetry means if you have an opposite x, you also have an opposite y. See how that goes in my table? For both opposites. That's what makes it an odd function. That's what you want to understand. Okay, now what I'm going to do on this is I'm going to show you kind of how this works, and we're going to just kind of put these numbers in as we go. So what I'm going to do on this, we're going to take this and plug it in to the function. So we're just going to, you can't just do a simple calculation on this, a little bit different. Plug the negative 2 in there, so you'd have negative 2 minus 2 to the third power. Okay, if you did that, you would have negative 4 to the third power, so that would be negative 64. So actually that point goes to negative 64. You got to plug it in the function, and we'll see discover what happens. Plug the negative 1 in. Okay, again, you're just plugging into the final product. So that's negative 1 minus 2 to the third. That's negative 3 to the third. So that's equal to negative 27. Okay, like that. And let's keep just crunching out each one of these, and then we'll kind of talk about what happens. If you plug 0 in, you're going to have 0 minus 2 to the third. So that's negative 2 to the third. So that's going to be negative 8. Okay, and then if we plug 1 in, we would have 1 minus 2 to the third. So that's negative 1 to the third. So therefore, that's negative 1. And then we'll finally plug the 2 in. So we have 2 minus 2 to the third. That's 0 to the third. So that's equal to 0. Okay, like that. Now, what I want you to do, and the reason I want you to do this is I want you to kind of see, these are kind of oddball numbers, but look how these things repeated. Negative 8, negative 1, 0. So it's going to go 1, 8 like that. So what's happened this time is you're shifting this way. And if you look at this right here, this point right here, that y value moved over there, so that point moved over 2 units. See, 1, 2 there, then you got that repeated. So what that's going to actually do is it's going to shift everything over 2, okay? And that's because it's inside the function. If your transformation is inside of the function, then it starts affecting x values. If it's outside the function, like what I have on the board, that's outside square root, then it affects y values. And that's one of the ways you begin to kind of sort this stuff out. So actually, once you get to realizing that this thing shifts you to the right 2, then here's how the problem, this is what really happens. This first point, really what you're doing is you're shifting that x value to the right 2 while you're leaving that. So you get the point 0, 0, 8 like that. When you shift that x value to the right 2, you add to it, so you'd end up getting a point like that. So what I want to go ahead and do on this then is let's go ahead and let's plot these points. And really let's just plot this and this, this and this, and those points like that. So if you do that, you would have a point like this. You would have a point 0, negative 8. Like that. You'd have a point 1, negative 1. And then you'd have a point 2, 0, and so forth. So this point right here would go over 1, 2, all the way over here. And then you would have your dot. This one right here would move there. So just kind of imagine moving all of those points to the right 2. And then you got basically what your final graph looks like is like that. Okay? That one's a little bit harder to see, but once you catch on to that, when you see that minus inside the function, you're going to know it takes you to the right 2. Now, predictably, what do you think would happen if that was a plus 2? That takes it the other way. But the whole key is it's where it is. It's inside the function. That's why it goes this way. Does that make sense? Okay? And a way to just kind of convince yourself of that is just to crunch the points out, and then you should be able to get that just fine when you do that then. Okay? All right, let's go. I'm not going to fill out the rest of those points. I just wanted to kind of show you how that graph goes. So with this one, the domain is everything. What's the range of this problem? It's everything also. Okay, if it's a cubic function, y goes infinitely down and infinitely up, so it spans the whole, all of the y values are taken up. So that's how that would go. Okay, I'm going to do 2 more of these. Just kind of to get the idea established here on this. Okay, and we're going to kind of do the same thing. Now this time, I purposely let these numbers off, I guess. What kind of numbers do I need to use if I'm doing a square root? 0 and positives, right? Okay, so that's why I left that blank, so you need to pay attention to that. So let's just put in 0, 1. Then I'm not going to put 2 in, I'm going to put 4 in, okay, because I know the square root of 4. Then I'm going to put 9 in because I know the square root of 9. That just makes it easier and it keeps you from getting decimals. And then you do this in your head. The square root of 0 is going to be 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And then that gives us some good points. So if we go through and plot that, that would give you the elementary function then. Okay, like that. So I'm going to go 1, 1, over 4, up 2. I'll go ahead and go over 9, and then I'll go up 3 like that. So that will give me the elementary function like that as y equals square root of x. Okay. Now again, what happens on this, I am going to go ahead and just crunch this out one more time, but I'll quit doing that. So what's going to happen on this, if you just plug these numbers in, like if you plug 0 in, you would have the square root of 0 plus 4. So that would be square root of 4, so that would go to 2. And you're going to start getting into decimals on this. If you plug 1 in, you would have square root of 1 plus 4. So that's really square root of 5. If you plug 4 in, you're going to start getting all these decimals. You'd have 4 plus 4 would be square root of 8. If you plug 9 in, you would end up getting 9 plus 4, so you'd get square root of 13 like that. But what's ultimately going to happen is that's going to move that to the left 4. So really, when you're doing these type of transformations, all you really got to do is just take every point on there and just slide it to the left 4 places like that. And once you learn that, then you'll be able to do that fairly easily. So that's what I'm going to do is this point 0, 0, what's going to happen is this. What I want you to kind of learn on this is the y values on this type of transformation, the y values are unaffected. What happens is that these things get shifted to the left, so that's going to go to -4. That's going to go from 1 over 4, that's going to be -3, and so forth like that. So what you do with this one really is you just are doing 0 minus 4. So that gives you the new point -4, 0. And again, that's just moved to the left 4 like that. Okay. And then what you would kind of have from here is you would have 1 minus 4 while the y stays the same. So that would translate to the point -3, 1. So it's just that point moves there and so forth. This point would go like this. You would have 4 minus 4, y value stays the same, so you'd have the point 0, 2. Now if you look at that on my table of values, there's your point 0, 2 like that. So you would have this next point like that, and then that would be roughly how your graph goes, is like that. To me, that's the hardest transformation for students to learn, is that one. But what you want to kind of get in your mind, basically, is this. And I want to write a couple of things on the board to kind of get you going on this then. And just pay attention to this. You don't need to write this down. So what did the absolute value of x look like? That was the v, right? Okay. So it all depends on where I put the number. If I put the number outside of the function, then it changes y. So it makes y get bigger by 2. So that's going up 2. Okay. If I did this, if I did x minus 2, that's affecting x. It's inside the function. Anytime it's inside the function, y's are not affected, x's are. So what did we learn that one does? That goes to the right 2. Okay, like that. And then one other one, if you had x plus 7, that's inside the absolute value, therefore it does what to x? It makes it go to the left 7. So try to think of where that number is. It's either outside the function or inside. If it's outside, what does it do? Up and down. If it's inside, what does it do? Left and right. That's the idea, okay? Even if I put a negative there, that's outside of the function, so it affects y by reflecting it, see? That affects y, that affects y. Does that make sense? Okay, think of inside and out, and that's one of the best ways to kind of get all this stuff sorted out. Yes?
So for the points on the right that are like 0, 0, 1, and 1, why are we subtracting 4? Because in the original function it's added.
I know, that's backwards of what it seems like, okay? What I want, if you kind of look at this, what happens on this, we started with the point 0, 0, but ultimately we ended up with this point 0, 2 also. So if you go through and if you just crunch out the table, I guess the point I want to make is if you went further with points like that, you would pretty clearly see that's how that goes. Okay, and what I'm suggesting you do once you learn that that switches everything 4, then really all you do with your points is you leave the y's alone, and those things go to the left 4. Okay, and here's one way you can convince yourself of this, by the way, is let's take like that 0. Okay, Plug it in. What's 0 plus 4? Square root of 4. What's square root of 4? It's 2. Okay? Same thing with this. Plug negative 3 in. Negative 3 plus 4 is 1, right? Square root of 1 is 1. Okay? And it's almost backwards of what you're thinking would seem logical. A lot of times students are going to think that's plus, so I go that way. It's opposite on this is the way that works. Okay? All right, now let's see. This one, the domain would be, that's the green graph. Where does the green graph start? Negative 4, so it goes negative 4 to infinity. So that's negative 4 to infinity. And what's the range? 0 to infinity. Okay, the smallest y value is 0, so it's 0 and then beyond like that. Okay, any questions about that? Okay, all right. That was the one that's a little bit weird in the way it works. I'm going to do one more like that and just kind of show you how the points transform themselves. So this one again, the absolute value was the v, and just do this in your head. Do the absolute value of all those numbers, and then you just want to plot those points. Okay, so if I go ahead and plot those points, got negative 2, 2, negative 1, 1, and so forth, and that elementary function is going to go like that. Okay, what's the minus 3 going to do? It's inside the function, so it's left or right. Which way is it? Right. It's going to go to the right. Okay, so it kind of goes like this. So what you can do is instead of filling that table out, what I want to do is this, is just make these, see what you want to do is when you write out the transformation of these points, don't change the y values. Okay, just leave these y values the way they are. And this is kind of how I want you to think about the transformation like this. And then since we now know that goes to the right 3, just make that get bigger by 3. The y is unaffected, x is affected. So in your head, just do this. Negative 2 plus 3 is 1. 1 plus 3 is 4, and so forth. You see what I'm doing there? Okay. So, and you can write that down if you need to. That would be negative 2 plus 3. The x value goes up 3, so it's going to go to 1. This one would be 1 plus 3, so that goes to 4. That would be a new point. This one, negative 1 plus 3 goes to 2. This one, 2 plus 3 goes to 5. And then finally, this one, 0 plus 3 goes to 3 like that. Okay, now I'm going to plot those points, and if you plot those 5 points, you'll pretty clearly see that it goes to the right 3. Okay, so I'm going to go ahead and plot these points right here, and then that'll give us what the final product looks like. So we'd have a point, looks like 1, 2. We'd have a point 2, 1. Have a point 3, 0. 4, 1. And then finally 5, 2 like that. And you can tell now that I put that on there that it went to the right 3. Okay? And one other thing I want to show you on here is this. So this is real simple if you do this. Take like this point. See that 4? What's 4 minus 3? It's 1, okay? Look at this, 1. What's 1 minus 3? Negative 2, but the absolute value of negative 2 is 2. That's the only way you're going to convince yourself of how it works is to plug in x values and see if they match those same y values, okay? So what I wanted you to see is the y values are unaffected. It's the x values that are affected. All right, is that good? That's the weird one, okay? The rest of them aren't that bad. That to me is the one that's the hardest for students to grasp. Okay, let's go to the next thing. We're going to look at stretching and shrinking. Then what we do is we try to put all this stuff all together, okay? So let's see, when I do this, again, we're going to do an elementary function, okay? So we're going to do on this one, we're going to start by doing x squared. Again, you just fill this out in your head. All you do is just square those x values. So that would be 4, 1, 0, 1, and 4 like that. That'll give you the parabola. So I want to go ahead and get that plotted. And then that will give what we call the elementary function like that, okay? Now, here's kind of the key thing that I really try to get students to understand is what I'm doing is I'm putting a 2 there. That 2 is outside of the squaring. And if it's outside of the operation of squaring, it's the y value that gets changed. Okay, that's what you want to get solid with. So actually, all you do on this problem is you're just multiplying those y values by 2. You're doing 2 times that. So you're doing 2 times 4 is 8, 2 times 1 is 2, and so forth. 2 times 0 is 0, then you got 2 and 8 like that. Okay? Now again, it's impacting the y values. So let's see what this graph looks like. So now you'd have negative 2, 8, negative 1, 2. You still have 0, 0, 1, 1, and then you have that like that. Okay, what happened? It stretched it, right? Okay, what happened is it's not that it's moving up or down. Those y values got doubled, so it's stretching it. We call that a vertical stretch because it's like you're pulling on that parabola that way. Okay, that's a vertical stretch. So that would be what your final result looks like. On this one, your domain would be all real numbers. What's your range? 0 to infinity like that. Okay? So that's what's going to happen. Okay? What if you did this? What if you did 3x squared? What's that going to do? It's going to make all the y values triple. And if it makes the y values triple, what happens? Stretch. Does that make any sense? Okay? That's the idea. So again, anytime that you're outside of that elementary function, the y value is either going to go up or down, or it'll stretch or it'll shrink. Those are the only possibilities there are. Okay? Okay, let me show you what happens on this next one. Then we want to kind of begin to start kind of putting this together and combining all this stuff together. Okay, so this time we're going to do the absolute value. So that would be 2, 1, 0, 1, and 2 like that. That's the V shape. We've done that several times. That's one of the classic elementary functions. So that's going to go like that. Okay. Now that 1/2 is outside. So what does it affect? X or Y? That's Y if it's outside of that absolute value. So what it's going to do is it's going to cut everything in half. So you're going to have like 1/2 times 2 is 1. 1/2 times 1 is a half. 1/2 times 0 is 0, and so forth. So you just have the function values are going to change like that now. Okay. Now, if you go through and plot these things now you would have negative 2, 1. So that point looks like that. Then you would have, let's say, negative 2, 1 is there. Then you would have negative 1/2, 0, 0, and so forth like that. Okay, so what happened? Now it shrinks. Okay, what does it make it shrink? That's a fraction, isn't it? If you multiply a number by a fraction that's less than 1, the y values get smaller. So since the y values get smaller, everything flattens. So we call that a vertical shrink. Does that make sense? But really, when you get right down to it, it's just simple arithmetic of seeing how these numbers get affected. And this one, you'd have a domain of all real numbers. The range would be from 0 to infinity like that. Okay, that's the idea. So this is kind of what you're getting at. You have an elementary function. If this number is bigger than 1, it makes the y values get bigger. Does that make sense? If you multiply a number by a number bigger than 1, it gets bigger. So these things right here are stretching. How do I make it shrink? I put a fraction there, something that's less than 1. That's what causes it to shrink. And the smaller that fraction is, the more it shrinks. Okay, does that make sense?
So the top one was stretching too because it's got a multiplier?
Yeah, stretch would be anytime the number's bigger than 1. Okay, like this one that one was a stretch. That one was 2x squared. This one was a shrink because that number in front of that function is between 0 and 1. That's how that gets. Okay, if you understand how the math works, then you don't have to memorize all this stuff. You don't want to learn this by memorizing. You want to understand how the arithmetic works out. Okay? Is there any questions? Okay, all right. Now, what we're going to do is we're going to do horizontal. We're not going to probably do a whole lot with horizontal. I'm just going to kind of show you how this works. But what's different about this problem, remember what we did a few minutes ago, is we did this problem, 2x squared. And see, that's outside of the function. So that's what affected y. So that's what made it stretch or shrink. Now you're going to put that 2 inside of the function. So what do you think is going to happen? It's going to affect x. So it's like an accordion. Okay, so it's like stretching and shrinking this way. So it changes everything in the opposite direction. So if you have the number here, it's the y that gets changed. But if it's inside, it's the x that gets changed. So we're just going to crunch this out, and I'll show you how this works, and we'll kind of discover how this works out. So we just square the numbers, so that would be 4, 1, 0, 1, and 4 like that. Okay, then if I go through and put those together, I'd have -2, 4, -1, 1, 0, 0, 1, 1, 1, and again 2, 4 like that. So that is your elementary function like that. Now we're just going to crunch, okay? The only way you're going to understand is we just number crunch. So what I'm going to do is we're going to plug these numbers in. I'm going to do this just kind of at the side and just kind of see how this goes. So let's go ahead and take 2x to the second, and let's just one by one plug those numbers in. So if we do 2 times -2 to the second, that gives -4 to the second, so that gets 16. So that's going to go to the value of 16. So something's happening. You're going to see something's happening. Plug in the -1. You would have 2 times -1 to the second. So that's -2 to the second. So that's equal to 4, like that. Okay? Plug 0 in. You'll have 2 times 0 to the second. That would be 0 to the second. So that's 0 like that. And then plug in 1. You'd have 2 times 1 to the second. So that's 2 to the second. So that's going to go to 4 and so forth. Okay? And then finally, the last one, you have 2 times 2 to the second. So that's 16 like that. Okay? I'm just plugging in and doing pretty basic arithmetic. Now if you plot these points, I'm mainly just going to plot these points right here. You would have the point -1, 4. So you have a new point there. You still have 0, 0. Then you have 1, 4 like this. Okay? So actually, 2 things happen on this problem. So what's happening, now we're talking about this way now, right? So what happened? Shrink. We call that a horizontal shrink. So you would want to write this down like this as a horizontal shrink. But there's another way you could say this too. How about if you talked about vertical? What happened vertically? It stretched. And those things, by the way, are always opposite. So if you shrink this way, you're stretching that way. If you stretch this way, you're shrinking this way. Okay, it's always opposite of each other. But generally on this, like if you're doing your homework and they say, like on a test, if I said, what's the transformation? You could either give me horizontal shrink or vertical stretch because it's the same thing. Doesn't matter. Just good to know that they're both how they work in opposite directions. Okay, so we'll kind of do this next one, and I'll show you how this works. And it all depends on what the value of that number in front of the function is. Okay, so let's do this one real quick. This one is absolute value. So you're going to have the V shape. And we'll go ahead and start that one off like this. So just put those numbers in. And then we'll try to go through and discover, kind of seeing what happens on that. So that's your elementary function. That's your y equals, that's the absolute value of x like this. Okay? So I don't know why I have a 2 there. That should be 1/2 x. And I want that to be a fraction. Okay? So what we're going to do is we're going to work with 1/2 x. And again, we're going to do the same thing. We're just going to plug those numbers in. Okay? So if we do that, we would have 1/2 times -2. That would be the absolute value of -1. So therefore, that would go to 1 like that. Okay? Plug -1 in. You would have 1/2 times -1. That would be absolute value of -1/2. Therefore, that's a half like that. Plug 0 in. Do whatever you can in your head. 1/2 times 0, that's absolute value of 0, so that's 0 like that. Now it's predictable on this what you're going to get because it's got this symmetry. So that's going to be 1/2 and that's going to be 1. We've already calculated that, so we do that. Okay, now if you plot these points, we would have -2, 1. So that point goes there. Okay, we would have -1/2. We'd still have 0, 0. So basically your graph would kind of go like this. Okay, so if you're going to do horizontally, what happened? Did it stretch or shrink this way? So let's stretch. How about this one? Shrunk, okay, like that. So what we would say on this is we would say this one is a horizontal stretch. So what you're trying to kind of do with these two examples is be able to look at the problem and know why it happened, okay? And this is hard to remember, but the idea on this is that number is bigger than 1. If that number is bigger than 1, that's what causes that thing to horizontally shrink, okay? If that thing's a fraction between 0 and 1, that's what causes it to do that, okay? That's the difference between the two, okay? All right. Now, I'm going to give you a break here in a second, but I want to show you, what, just before I do that, I want to just do one little quick thing on the board here for a second. And so this is kind of what we're looking at here and trying to get kind of put together. I'm just going to work like with the absolute value values. Okay, so you know that that's the B, right? Okay. Now, let's think about what happens if the transformation is outside of the absolute value. That's kind of what I'm trying to get you to do. Okay, what if you did that? What would happen? Up 7. Why? Because it makes the y values get bigger. That's why. It makes all the y values get bigger by 7. Okay, what if I did absolute value of x minus 2? What does that do? Down 2. Why? Because the y values get smaller by 2. I want you to understand that instead of memorizing all this stuff. Okay? The other possibility we talked about is, okay, we can put a negative there. What does that do? Reflect. Why? Because the y values go to opposite, okay, right? That's how I reason this out, and so if I forget, I can figure it out. So that reflects. Okay? Here's another one. What if we put 2 times absolute value? That's outside, so it affects y. What does it do? Stretch. Why? The y values double, that's why. If y values double, you're stretching it. Okay? That's what we would call a vertical stretch like that. Okay, what if you had a half times that? What happens? Vertical shrinks. Why? Because the y values get cut in half. That's why. They flatten. Okay? So that would be what we call a vertical shrink like that. So that's how you want to kind of sort that out, but the outside transformation is like that. Okay? If it's inside's a little bit harder for students to grasp, I think, at the beginning. But this part's pretty easy to get down, okay? What happens on that is it's inside the absolute value. So what does that mean it does? It means everything is affected this way, okay? What does that do? Left 1. That's almost backwards of what you think. Okay, what if I do this? What does that do? Right 2. Like that, okay? That's the idea, okay? Then the other one's the horizontal. I'm not going to worry too much about the horizontal stuff too much. Basically on the inside you want to be really clear on that, and on the outside you want to be clear on that, okay? All right, does that help? If you know why it works, you'll remember it. Otherwise you'll forget it. Okay, go take a 10-minute break and we'll come back and wrap this up. A little bit more like this. Okay, so the first thing I'm going to do is I'm going to do this example, and you know, I mean, you could do this without knowing anything about transformations. You could make a table of values and just plug everything in and calculate, okay, like that. What we're trying to learn how to do is how to do transformations. So the very first thing that I want you to do, this is a squaring function. So what we're going to go ahead and do is we're going to just do the elementary function. We're going to try to just do that elementary function and then the final thing, okay, like that. Instead of doing like 4 or 5 stages, I want to show you how everything works, and you can immediately get it to that final stage like that. Now, this is something you want to, you don't have to memorize it because you can always figure it out super easy. So I'm just going to write a table of values, but you don't have to. I don't care about that. So let's just square the numbers, and let's go ahead and plot the points on that as our elementary function. So I'm going to go left 2 up 4, and then -1, 1, 0, 0, 1, 1, and then 2, 4 like that. Okay, and then I'm just going to use like a dashed line to represent that as the graph of the elementary function like that, okay? Now I'm going to show this. I usually I'll show this a little bit different sometimes than other teachers or textbooks because I want you to really know how the transformations work. So we're going to make kind of a table of transformations. That's the way I'm going to teach you how to do this. Now, I want you to just pay attention to this. You do not have to write this down unless you want to, but I want to show you how order of operations works on transformations. Let's just say that you had x equals 5. Just say it's equal to 5. I'm going to plug that in, and I would have 4 minus 2 times 5 minus 3 to the second. Because when you do transformations, it matters what order you do this in. So if you were going to solve this arithmetic problem, where would you start in solving that arithmetic problem? Inside parentheses, right? Now what that does is that part of the problem right there, inside the parentheses, that's what does the left-right stuff. Okay, so that's the way you should always work with transformations, is you should always do your elementary function, then you do your left-right. And you don't have to memorize that, because if you solve that problem, you would think about the order you would do. You would do that, then you would square, then what? Then multiply by -2. And what that would actually do is stretch and reflect at the same time. And then the final thing you would do is add 4 to it, and that moves everything up. So in a sense, what you're doing is you're doing that right 3, then you're multiplying it by -2, which stretches and reflects, and then you're doing that add 4, which makes it go up like that. Now the way I'm going to teach you how to do this is I'm going to have you fill out a table here this way, like this. So these are the points that we got. I think one of these is wrong. That one is 2, 4. So you need to change that. That's a mistake. Okay, so the first thing we're going to do is we're going to go, if you look at this part of the problem, that's going to tell you that you're going to go to the right 3. So I want you to just make a column for right 3. Okay? Now what we're going to do next is you're going to multiply by -2. Now that's going to stretch and it's going to reflect. What I would do on my chart, just do this. Just write down that you're going to multiply y by -2. And that'll give us a column like there. And then, so you've done that, you've done that. The final thing is you're going to add 4. That's a positive 4, so it's making that go bigger by 4. So that really means that you're going to go up 4 like this. Okay? So we're going to do it this way, and then I'll show you kind of how this works. So start this way. Okay? We're just going to do right 3. Now when you move points to the right 3, the y value does not change. So what I would do on this is I would just go through and go ahead and get those y values in there. And they're not impacted by this first step because we're just moving things left to right like that. Okay, so we're going to do that. Okay, now you just do this in your head. Make that number get bigger by 3. All of those x values are going to get bigger by 3, so you do that in your head. So if you do 2 plus 3, you're going to get 5. If you do 1 plus 3, you're going to get 4. 0 plus 3 is going to give 3. -1 plus 3 is going to give 2. And then -2 plus 3 is going to give 1. Okay, that's what's going to happen. Now, I'm not even going to bother blotting those points. You can if you want to. But that's what that aspect of the problem is doing, right? Just that aspect. And that's what you have to do first. Okay? Now you start looking at the second part of the problem. And it's going to reflect, and it's going to multiply y by 2. Just do it at the same time. You don't have to do 2 extra steps on that. Just do this. So when you go to this next step, it's the y's that change. So just bring the points down, but do not change those x values at all. Okay, that's all set now. We got that set. Okay, now you just do this in your head. You're multiplying all the y's by -2. Do that in your head. That's -8, -2, 0, -2, -8. Okay, that part of the problem is going to change everything like that. So just double and make it a negative. So let's see, that'd be -8, -2, 0, -2, and -8 like that. Okay, everybody okay there? Okay, again, that's what that part of the problem did. Now that's a +4. Don't get confused. Don't think that that's making it go down 4, because that minus goes there. That's a positive number. That's making everything get bigger by 4. So the last stage on this is to do this like this. So what we're going to do on this stage, again, the x values are set. That's what you try to get set first on these transformations, is that. Now what you need to do is just go through and make all of those y values go up 4. So in your head, just add 4 to each of those numbers, and then you're going to have what the final graph looks like. So do that in your head. Negative 8 plus 4 is negative 4. Negative 2 plus 4 is 2. 0 plus 4 is 4. Negative 2 plus 4 is 2. Negative 8 plus 4 is negative 4, like that. So what you have is, those are your final points like that. Yes?
What about the exponent?
Okay, we already really that's a good question. We already took care of it right here.
Okay.
Yeah, because I mean, that part is sort of like the elementary function part of it. You're just doing the other things like that, but that's a good question. Okay, go ahead and plot those 5 points, then you'll see what this thing looks like, okay? All right, so let me widen this just a little bit, and then we'll get this put together. So we have 1, negative 4, and then 2, 2, and let's see, 3, 4, and then 4, 2, and then finally 5, negative 4, like that, okay? So basically your final product, the parabola, is doing that, okay? Now what I want to do on this now is see if you can see all these transformations and how they work in here like this. Okay, so first of all, can you see that every point got moved to the right 3? Like this point right here, 1, 2, 3, there it is, okay? This point right here, 1, 2, 3, well, there it is, okay? You can obviously see it reflected, right? Turned upside down. Does it look like it's stretched? That's a little harder to see, but it is. And then what did we do? We moved everything up 4. Look at this point here. 1, 2, 3, 4. Yeah, that got moved up 4. So you can do transformations in all steps like that. A lot of times what a textbook will show you to do, I don't care if you do this. I mean, you could actually do this in steps. You could plot those points, and all that's going to do is move everything to right 3. Then you can plot these points. That would show you how it reflected and stretched. Then you could do that. But I don't care. All I want is the final product. Okay? And I like to use this table because it kind of helps you see how the transformations go. My math lab's crazy the way they do this. All you're going to do is put in the function. There's a little sliding bar, and it's going to say like right 3. So you slide it. Then it's up 4. You're going to slide it, and it's going to do all the work for you. Okay, to me, that doesn't help students very much, but it makes it easier for you. But I want, like, for testing purposes, usually I do a problem like this where you fill in that chart because I want you to prove to me that you know the order these transformations go in. Okay, that's what I'm after, okay? Like a lot of times students don't learn this very well because of the way my math lab works on that. Okay, so let's see, going to work with probably I'm going to do one more of these, and then I'll just have you do one of them just outside of class yourself. Let's do this one just kind of together here. So again, what I've already done, or actually that's a square. I'll let you guys do this one outside of class. You could get it done before you leave if you want to. Let's do the absolute value like this. Okay, so what's happening with this one is the key thing is you got to know the order of how these transformations go. The first thing is we're going to go ahead and we're just doing absolute value of x. And I'm just picking these x values. Okay, and let's fill in those x values like that. All you're doing is the absolute value. So that would be 2, 1, 0, 1, and 2 like that. Okay, again, we're just going to do transformations. Go ahead and plot those points on your graph. And then we're going to just label that as the elementary function. Okay, like that. So that's going to be y equals absolute value of x. Okay, now let me write down what we're doing. We're doing what? Y equals negative 2 times the absolute value of x plus 4. Now you got to know the order you do this in. You got to be really careful about that. So think of order of operations of arithmetic. Okay, what would be the first thing you would do? If x was 1, then what would you do next? Would you add? Or would you multiply? Multiply. So you got to do order of operations. So really the first thing you're going to do is that's going to do two things. It's going to reflect and stretch. Okay, but on your table, just write it like this. Just write, this is going to multiply the y's by -2. Okay, and again, the thing I want you to get clear on that is this thing is outside of absolute value, like I have on the board. That's affecting y. That's multiplying y by -2. Just do this in your head. Okay, so what's going to happen is the x's are going to stay the same. And then in your head, just multiply the y values by -2. So 2 times -2 is -4. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. And then 2 times -2 is -4. Okay, that takes care of that transformation then. If you plotted those points, you would clearly see it reflecting and getting stretched. Okay, does that make sense? Okay, now what? Up 4. Okay, that's the last thing you do. Now see, that's always the last thing you do is up and down, because you always, in order of operations, add and subtract at the end. Okay, so now what that means is your x's are set. Okay, so just make all of the y values get bigger by 4, and then we'll plot it, and then you'll see how it worked then. So we'd have -4 plus 4 is 0, -2 plus 4 is 2, 0 plus 4 is 4, -2 plus 4 is 2, and then you got that. So that would be the final set of points that you plot, and then you got it. Okay, like that. Plot it, and then I hope you see how this thing worked out then. So let's see, we'd have -2, 0, -1, 2, 0, 4, and so forth like that. Okay? So we're going to kind of see if you can see how that works. You can see the reflection. Can you see the up 4? Yeah, okay, that point got moved up 4. Everything got reflected. It's a little harder. Does it look like it's stretched? You have to look at it. It's like it's stretched a little bit like that. Okay? That's just the way I teach it, is like that, so that you don't have to do every little step. When we get to the trig part of the class, towards the end of the semester, that's what I want to try to get you to do, is a basic graph and the final product in one step. Okay? And with a little practice, you can do it that way so that you don't have to do graph like 5 things. Then you'll be kind of confused about what that final product looks like. Okay, one of the ways that I ultimately test students over this on a test is problems like this. Because you can't do this on a graphing calculator. You actually have to do something on these things. So let me go through these 2 things. Then that'll finish that up, and then we'll get started into the next section. Okay, so let's go through and do this. And we're going to do this the same way. So we have f of x minus 2 plus 3. Now, this part right here is inside the function. What does that do to the graph? Right, too. It's inside. It looks different to you because it's saying f of something. Okay? What does this part do? That's outside the function, so what's the plus 3 do? Up 3. Okay? Now, you got to do the order of this. Remember, the last thing you always do is up, down step. You got to do that before you do that, because it's order of operations. So what we're going to do is, and you don't have to do this table if you don't want to. You can do it all in your head. But what I'm going to do is I'm just going to take each of these points and write them down. So that's like a point -4, 0. You have a point, what is that, -3, 2. Then you have a point -2, 2. Then you have 0, 0. And then it looks like we have, what, 3, -1. And then finally we have 4, 0 like that. So we're just going to make a chart, and we're going to do this. We're going to take everything to the right 2, and then we're going to take everything up 3. Okay? Well, like on a test, sometimes I require you to do the chart. Sometimes I don't. Sometimes I just say, see if you can get the whole answer to that. I don't care. But in this case, I want to go ahead and do that chart. So when you move everything to the right 2, the y values stay the same. So I'm just going to put those values like that. Let's just leave the y values as they are. And then we're just going to take all of those x values and make them get bigger by 2. So take all of those x values and add 2 to them. Make them go to the right 2. And you can do that in your head. So this would be -2. -3 plus 1 is -1. -2 plus 2 is 0. 0 plus 2 is 2. 3 plus 2 is 5. 4 plus 2 is 6, like that. Okay, yes?
Why are we adding 2 instead of subtracting 2?
Okay, because remember we did that, how the transformation would work like on the board? If it was x plus 1, plus made it go that way.
Okay.
And then minus made it go that way. We're not really plugging numbers in. You're just seeing that that is transforming it the right 2. That's what you're confused about. Okay, now we just make everything go up 3. So again, the x's are done. You get that out of the way first, and then in your head, you just make all of those y values go up 3 like that. Okay, so you'd have 0 plus 3 is 3, 2 plus 3 is 5, 2 plus 3 is 5, 0 plus 3 is 3, -1 plus 3 is 4. No. What's -1 plus 3, teacher? Okay, -1 plus 3 is 2, and then 0 plus 3 is 3, like that, okay? And then you go ahead and plot those points. Okay, so we're going to do these, and then you'll have what your final product looks like, okay? So it looks like we need to plot the point -2, 3. I'll put a dot there. Okay, got -1, 5. Okay, then we got 0, 5. I've got 2, 3, over 2, up 3. And then I got over 5, up 2. And then finally I got 6, 1, 2, 3, 4, 5, 6, and then up 3 like that. And then just connect those dots in the same way. And then that's what the graph of that one looks like, okay? And if you look at that, that's easy to see. Can you see that it moved to the right 2? Yeah. Can you see that it moved up 3? Yeah, okay? That's it. Okay, so the table on that, sometimes I require you to do it on a test. Sometimes I just say, here's the graph, draw the new one. You can do it on your head, okay? Because you can do that one in your head easy, okay? Okay, let's do one more like this. Now this time, let's not do the table on it. Let's just do this in our head. So what you're going to do is, what is that -2 going to do to that graph? I'll do things. It's going to reflect it, and what else? Yeah, this way, okay? Just think of that as multiplying the y value by -2, okay? And that's a good thing to write down. I'm not going to make the chart on this one this time, but what we're going to do is just multiply every y value by 2, okay? And you can do this in your head. Like this point right here is still going to be the same because the y value is 0, right? And 0 times -2 is still 0, okay? The y value of this point is 1, so what's 1 times -2? It's -2. So that point is going to go down there like that. Same thing here. That y value is 2. Hold on. Whoops, I'm doing the wrong thing there. Okay, this y value right here, this is the point, -3, 2. So if you multiply that y value by -2, it's going to become -3, -4. So that's going to go like that. Okay, same thing here. That's going to go like that. So the new graph is going to do like that. This point here is the same. Okay, this point right here, this is the point 3, -1. What does the y value become? 2. You're multiplying that y value by -2. Okay, so that point is going to become 3, 2. Okay, so you're going to end up kind of having something like this. You'll have that, the graph goes like that, and then this point's going to go like that, and finally this last point, that last point is 4, 0. Well, if you multiply that by -2, it's still the same. So that's how your graph would go. So what's happening on that one is, it's easy to see the reflect. How about the stretch? Can you see the stretch? Okay, that was up 2, now it's down 4, like that. If you can do it in your head, do it in your head. If you struggle to do it in your head, do it the other way. Okay? Either way, all right? Okay, you guys got any questions about how that's working? Okay. And then a lot of this, as you get more advanced with functions, particularly in trig and so forth,